Okay, in this video we're looking at some general rules that we need to be familiar with. F of 0. F of 0, guys, it basically just represents the y-intercepts. Remember, this comes from this notation of f at x that represents y. So when you say f of 0, we are basically just replacing x by 0. We let x be 0. That's why this is what we call the y-intercept. We are basically just letting x be 0 in this situation. So whenever we get the y-intercept, we let x be 0. And when you say f of x is equals to 0, we are basically letting y be 0, as you can see. Therefore, we are getting what we call the x-intercept. And when we say f at x is equals to g at x, okay, f at x is equals to g at x, basically at the point x, because these are basically the y values of two different functions, and for the same value of x, basically we are talking about the point of intersection of g and f. Basically, that's just represents the intersection of the two functions. These two different functions, g and f, they intersect at a certain point. F of x equals to g at x just talks about the intersection of the two functions, if I can just put it like that. And when they say f at x is greater than 0, f at x is greater than 0, what they mean by that, f at x is greater than 0, that's d. What they mean by that is that f at x is above the x-axis. Or sometimes they will say give us the value of x where f at x is greater than 0. They basically mean give them the values of x where f at x is above the x-axis. That's basically it. There's nothing hectic about that. And then this is the opposite of what we just spoke about now. F at x being less than 0, basically we're looking at the portion of the function where the function is below the x-axis. Just to demonstrate the two, I'll just maybe draw something here. This is the xy plane, and let's say we have this being our function, which is f, and then suppose I add another function, a straight line, which is our function g. This is the point of intersection. Okay, maybe let me use that color. These are the points of intersection. That's where f at x is equal to g at x. That's what C represents. When they say f of x is greater than 0, that's this point from here. Okay, let me use the yellow color. This is above the x-axis. These portions, this is where f at x is greater than 0. And f at x being less than 0, it's this portion. I'm just going to use, which color? Let me use blue. This is the portion below the x-axis. Okay, and we can have a portion where, what is it, f of x is greater than, I'm on f now if you are not catching up. I'm on f where f at x is greater than g at x. That's basically a portion where the graph of f is above the graph of g. Okay, which portion is that? We are still using the same sketch. The graph of f is greater than the graph of g. This is the portion. You can see f is above g for this piece, and also here f is above g, as you can see, that small portion there. So yeah, and then when we talk about the portion where I'm on g now, f at x is less than g at x, that means f is below the g at x. Okay, which portion is that? F is below the g. Okay, you can see this portion here. F is always going to be below g for that portion. That's between those points of intersection. And now we can speak about a portion where f times g is greater than 0. That basically means a portion where f of x multiplied by g at x is greater than 0. That's basically the portions where the two are on the same side of the x-axis, either above or below. So both of them have to be either above the x-axis or below the x-axis. Where do we have those situations? We can think of until here and until here. So as you can see, I just drew two straight vertical lines which were supposed to be straight. I know they don't look straight like that, but just bear with me for me to explain my point. So look at this side going there. These graphs are above the x-axis, all of them. So they are both positive. So when you multiply positive and positive, you're going to get a value which is positive. So that's the portion that they are talking about. And you look at this middle portion from here to here, one is above, the other one is below. So positive times negative, it's what? It's negative. So that section, we are not talking about it. And then the other section, which is from this point of intersection going there, you can see that F is above, that means it's positive. G is below, that means it is negative. Okay, so that portion we are not talking about it, because when you multiply negative and positive, you're going to get negative, and we're trying to get a portion where f at x multiplied by g at x is greater than 0. So we're not talking about that. But now when we say f at x times g at x is it's what is negative, we're basically just going to look at portion where one is above, the other one is below. So these portions are this portion as well as this other portion. I hope you get what I mean by that. Or does it even make sense for those who are first time what attempt or candidates? I don't know what you call them. Yeah, but okay, let me try to make it make sense. So you have this portion from here to here. Okay, you can see that f is this line which is above, that means it's positive, and then g is this, that was g actually, which was positive, and f is this one which is below, that is negative. Positive times negative is negative. So that is the portion that we are talking about when we look at the portion where the multiplication of the two, they give you negative. That negative just means less than 0 basically. And we can have a portion like this where f is positive, g is negative, and this portion, they are both positive. So you basically just needed to put these straight vertical lines and then identify regions where positive, negative for each of the functions, and then you can now answer this piece, because divide a positive and a positive, you'll get something which is greater than 0. Divide negative by a negative, you get something which is greater than 0. And yeah, and increasing, decreasing basically refers back to what I spoke about. The y values increase with an increase in the x values. That's an increasing part of the function. For instance, when you have this, as you can see, this piece, it's increasing, the y values are increasing with an increase in the x values, but this piece, the y values are decreasing with an increase in the x values. So that's a decreasing, increasing. Okay, we are done. Now this is signs. Okay, let's be clear here. So we are going to be using these signs a lot. For those who are right-handed, just hold your you can just hold your head with your right hand, and then you can see this is it an elbow? This piece of your hand is always going to point. It's going to be pointing in which direction? To your right hand side, if I can put it like that. So your right hand side is for greater, left is for less. Okay, you can just hold your head with both of your hands, and then left is always, usually left is taken as the weaker hand. So you can use that one to remember which one is greater, which one is less, so that you don't confuse the two. Less is left, right is greater, if you hold your head with both hands. Okay, and when they say greater or equals to, they just put some equal sign, a line below the signs, and less or equals to, they also do the same. So whenever we're using less or equals to or greater or equals to, we need to use square brackets. Okay, whenever we say less or equals to, or we say greater or equals to, we need to use square brackets. But when we just say greater or less, we don't need to use square brackets, we use circular brackets. The reason for that is because the square brackets indicate that we are including what we are going to be putting either on either side of the inequality sign. That's why we use the square brackets. It's just to indicate that we are including whatever value. When you say greater or equals to 4, that means we are starting from 4 going upwards. So we're including the 4. So we will use square brackets in another notation of representing the same functions. But you will see when we look at the domain and the range, the actual way of applying these things. For now, I'm just explaining. It's fine. We have asymptotes. These are just, we spoke about asymptotes, guys. So nonetheless, if we are going to be required to determine the asymptotes, remember asymptotes, these are straight lines. So straight lines that graphs keep approaching but they never touch. So always when you are going to indicate asymptotes, these are lines that the graph will never touch, so you're going to use circular brackets to exclude them. You will see how we do that in the next couple of videos. I think after 2 or 3, after about 2 videos, then we'll be doing a couple of examples. For now, I'm just trying to make sure that we are all familiar with the definitions and the general rules. We keep it moving. See you in the next video.